In a previous video, I talked about parsing data as you get it from a user, using things like scanf, getS, and fgets. In this one, I want to talk about C's tools for parsing data that's already in a string. The simplest thing for getting data out of a string is the set of functions like a to I, a to f, and so on. These all do the same kind of thing, they just look for different types of numbers. So I'm going to call these the atoX functions. If your string just contains a number, these atoX functions can work. They take one parameter, that is the string, that contains the number, and the return type is the type of data that it will look for. Here's an example of each one. For each, I have a string that contains a number of that type, and you can see that the atoX functions correctly parse them to give us the type that we were looking for. However, there is a serious weakness to these. If they can't match the type you're looking for, their behavior is undefined. Depending on your compiler, it might return a 0. It might return a partial number if the string started with something that looked like a number. Or it could return some other arbitrary value. Worse yet, there is no way to detect that that error has occurred. That's a serious problem, so these are pretty risky. It's so risky that clang_tidy is giving me a warning about it and suggesting that we use the strtox functions instead of the atoX functions. I'll get to those in a minute, but let's look at sscanf first. Sscanf works just like scanf, but it has an initial parameter that is a variable that holds the string we want to parse. So the parameters are the string we want to parse, a format string like the scanf and printf use to describe what's in the string, and then a list of pointers to variables where the data associated with the placeholders in the format string should be stored. The return value for sscanf is the number of placeholders that it was able to match. For example, let's say we have a string that holds an age, which is an integer, and it also holds a name. I can use this sscanf to store the age and name into variables. When I run that, the count that it returns is 2, and both of my variables have been updated. If the format string doesn't match what's in your string, sscanf will just give up. For example, if I incorrectly thought that there were 2 integers in the strings before the name, it would correctly get the age, but the variables named wrong and named 2 would not be updated at all. I could detect this by looking at the count of things that it knows it matched. Since that's a 1, I know it only updated the age. The fact that the %s format will match anything up to the first space means that my results are kind of weird if I accidentally reverse the name and the age. If I do that, it happily matches the 61 as the first string and stores that into name. But then it can't match the age. So age is unchanged, and the return value is 1 to reflect that it only matched the first placeholder in the format string. You've probably noticed that clang_tidy is still giving me a warning on the calls for sscanf. Yes, those little yellow squiggles. This is the warning it's giving me. Just like with the atoX functions, clang_tidy is concerned that sscanf isn't giving me an actual error if it can't match that integer. To me, it seems like the return value is enough for me to be able to figure out whether something went wrong, but this is a common complaint about sscanf. It's recommending that I use the strtox function again. Let's go look at that. Like the atoX functions, I'm going to talk about the strtd, strtl, and the rest of the functions like them as the strtox functions. These functions have 2 or 3 parameters and return the number that it found in your string. Most use 2 parameters. I'll talk about that third parameter in a minute. The first parameter is a character pointer to the string you want to parse, and the second is a character pointer pointer. In other words, it's a pointer to a character pointer. It's going to use that as an output parameter to give you back a pointer to where the number you found ended in your string. Clearly, we need an example. Let's use that age and name thing that we used before. In this code, str points at my string that has 61 Merlin in it. I've declared next to be a character pointer, and I'm passing the address of next into the second parameter. When I'm finished, I'm printing out the value that strtd returned and whatever next points at, but I'm putting that in quotes so that we'll be able to see any white space in it. To see what it's actually doing, let's put a breakpoint on the printf statement and look at the variables. We can see that str still points at the original string, and val has the 61. Next points at the string that is space Merlin, which is what is left of our string. It's what was after that 61. If we look carefully, we can see that the address in next is only 2 bytes beyond the address in our string. So next is pointing into the string that we were already parsing. That means that we can continue parsing the string from that point. For another example, let's get 2 comma-separated integers out of a string. First, the strtox function that I'm going to use here is string to long. There isn't a string to int for historic reasons, but we can down convert it afterwards if we need to. String to long is an example of a strtox function that requires 3 parameters. The third parameter is what base the number we're parsing is in. So we could use this to parse hex values, binary values, or any other base we wanted, but I'm going to stick with decimal. My first call is going to return the 71, which I'll store into first, and put next right on the comma. That's the first character after the 71. I increment next to get it off that comma and pointing at the 4 of 42. So my second call will put the 42 into second and move next to the null terminator of the string. Notice that I didn't need a delimiter after my number if the thing in the string is not a number. This will work. And yes, my printf is adding those quotes again so that we'd be able to notice white space if there was any. This is the first time that Clang Tidy isn't complaining about errors not being reported. Why is that? Well, if the start of the string doesn't match the kind of number you're looking for, the strtox functions will return 0. Well, that sounds like the atoX functions, no error reporting at all. However, it will also set that output parameter to point at the very beginning of the string. So let's look at this example. My string doesn't start with a double, so strtd returns 0. See, val2 is 0. In addition, look what happens when I print out the string that next2 points to. It contains Fred. In fact, when I compare next2 to str2, they are equal, and I know that there's been an error. So I agree with Clang Tidy. The strtox functions do let us know if an error has happened. That ability to parse one thing and already have a pointer pointing at the next thing in the string is pretty powerful. We have one more function for parsing strings that builds on that, strtok. The goal of strtok is to separate a complex string into the parts that make it up, which are called tokens, hence the name strtok. For example, if this is my string, it would have 3 space-separated tokens. The first thing to know about strtok is that it's going to modify the data in your string. Remember that strings in C are null terminated. Strtok is going to make each token a null terminated string, so it has to be able to edit your string to put those nulls into it. The compiler puts all string literals in a section of memory that is not editable. If you want more information about where the compiler puts different things, check out the link above. Since this string literal isn't editable, we can't pass that into strtok. So I'm going to use strcopy to copy it into a local char array. That'll be editable, so strtok will be happy with it. Strtok has 2 parameters, a pointer to the string we want to parse, and a string containing the characters that could terminate the token that we're looking for. These are called delimiters. Its return value is a pointer to the first token it found. So let's ask strtok to find our first token. I'm passing in the pointer to the string that's in our local char array and a space as the delimiter. Strtok is going to look for that first space and replace it with a null, and then return a pointer to the start of that token. That sounds a bit magic. Let's look at what's really happening. After the call on strtok, cur will point at the beginning of our char array. But look right here. Our string started with a space in this location, but now there's a null there. So the 32 has become its own null-terminated string. If we print it out using the %s placeholder, we'll only get that 32. Yes, the contents of my array have been changed, and it feels kind of like I've lost the rest of that data because of that null. But don't panic. Cur has the first token. We can use atoi to convert it to an int. That part worked just fine. We haven't really lost anything. If we wanted to, we could walk down that char array to move past the null that got inserted. But we don't have to do that. Interestingly, strtok has kept a pointer to the unparsed part of the string itself. If we call it again, passing null for the character pointer, it will continue to parse the string that you already gave it. Yeah, that's weird, but I swear it's true. So if we want that second token, the 426, we can call strtok passing null and a space for the delimiter. It'll find the next space, replace it with a null, and return a pointer to that token's part of the string. Again, we can atoi that if we want it to be an int. We can use one more call on strtok, again passing the null to tell it to just keep going with the string that it's working on. But this time use a null delimiter to get the last token from our original string. Since that's a bit weird, let's summarize strtok. The goal of strtok is to find and separate the tokens in a string. Strtok doesn't move the tokens at all. It replaces the delimiters with nulls, and that essentially makes our one null-terminated string into a sequence of null-terminated strings, one for each token. After each call on strtok, all the rest of your string is still there, but string operations won't find it because they all pay attention to the null terminator that strtok added. Strtok remembers what string it has been parsing and will continue to work on the same string if you pass null as the character pointer argument on subsequent calls. When you want to start over with a new string, just make the first call on any new string pass in that new string. I hope that gives you some tools that you can use to parse strings. Please let me know in the comments which ones you use, and if you have any questions, I'd love to hear from you.